Why is current CFS ME research so confusing? Imagine trying to solve a puzzle where the pieces keep changing shape and size. That's a bit like what researchers face when studying chronic fatigue syndrome and myalgic encephalomyelitis. These illnesses are incredibly complex because they affect many parts of the body, including the immune system, the brain, the metabolism, and the autonomic nervous system. Symptoms can vary a lot from person to person, making it hard to find a single cause or a clear pathway. The hallmark symptom, post-exertional malaise, causes symptoms to worsen severely after even minimal activity. This makes designing studies tricky because patients experience the illness differently, and researchers have to account for these variations. It's possible that CFS and ME are not just one disease but a collection of subtypes with different underlying issues, which adds another layer of complexity. Another big challenge is that there are no reliable laboratory tests or biomarkers for these conditions yet. Doctors relying on clinical criteria and ruling out other illnesses to diagnose patients. Without objective markers, it's hard for researchers to identify truly similar groups of patients for studies. Some promising research is underway, like genetic studies and microbiome analyses, which might lead to better diagnostic tools in the future. But for now, the lack of clear tests makes it difficult to compare study results or develop targeted treatments. The history of CFS and ME also plays a role in the confusion. For many years, some in the medical community thought these illnesses were psychological or mental health issues rather than physical diseases. This led to mistrust between patients and researchers and influenced how studies were designed and interpreted. The controversy around the PACE trial, which tested therapies like cognitive behavioral therapy and graded exercise therapy, is a good example. Critics pointed out flaws in the study design and bias, and later reanalyses showed that the benefits were not as clear-cut as initially claimed. These debates have made it harder to reach consensus and have sometimes slowed progress. Research methods themselves have also contributed to the confusion. Some large studies have faced criticism for poor design, such as unblinded protocols, relying heavily on subjective reports, or lacking transparency. When reanalyses show different results from the original findings, it creates doubt about what is true. This inconsistency makes it difficult for the scientific community to agree on the best ways to diagnose or treat the illness. Funding is another hurdle. Compared to other chronic diseases, research into CFS and ME has often been underfunded. Limited resources mean fewer large-scale, high-quality studies can be conducted. Some research centers have faced cuts that delay progress and make it harder to explore all the promising leads. Without enough funding, it's challenging to gather the data needed to understand these illnesses fully. Finally, recent studies are starting to uncover biological clues that support CFS and ME as real physical illnesses. For example, some genetic research and microbiome studies suggest there are underlying biological differences in patients. But these findings are often preliminary and sometimes shared as preprints before peer review. This evolving research can seem confusing because new hypotheses keep emerging, and earlier ideas are revised or set aside. It's a sign that science is moving forward, but it requires patience and careful interpretation. In summary, the confusion around current CFS and ME research comes from the illness's complexity, the lack of definitive diagnostic tests, a history of controversy, inconsistent research quality, and limited funding. While recent advances are promising, the field is still developing. It's important to understand that each person's experience is unique, and ongoing research aims to bring clarity and better care. Always consult healthcare professionals for personalized advice, and remember that science is a process of discovery that takes time.